This is an example of a reaction where aluminum reacts with some copper 2+ to make aluminum 3+ ions and copper metal. And so you can make then like pure copper metal if you have the ions this way. Let's focus just right now though on the aluminum. So I'm going to ignore the stoichiometries of 2 in front and just focus on the aluminum. And if that's the case, you've got aluminum as a solid and aluminum 3+. So again, remembering that electrons are -1 and we need to have the charges balance on both sides, then we're going to add 3 -1 electrons to the product side. Because +3 from the aluminum 3+ and 3 times -1, -3 from the 3 electrons goes to 0. And that's what pure aluminum is by itself. So in this case, again, because the electrons are products, or because the oxidation numbers are getting more positive, you're going from 0 to +3, either one of those reasons, that means aluminum is oxidized. It has lost electrons. But this is a big field, and sometimes instead of calling it an oxidized species, they'll call it a reducing agent. A reducing agent is literally a chemical that allows something else to be reduced. It doesn't make a lot of sense to me, I'll be honest, but I'm just the messenger here. I did not make these rules. But for us here in Chem 221 through Chem 223, just realize that something that's oxidized can also be called a reducing agent, all right? And different fields of study will sometimes focus on reducing agents or oxidized, so be careful. They mean the same thing. The other part of this reaction is the copper. So again, ignoring the 3 stoichiometries in the balanced overall reaction and focusing just on the ions, copper 2+ plus 2 electrons goes to copper metal. So again, copper 2+ needs 2 electrons to become neutral. Notice that copper is going from +2 to 0. It's becoming less positive, or the oxidation number is decreasing. For any of these reasons, we would say that the copper 2+ is being reduced, all right? The copper here is gaining the electrons to become copper metal, and something that's reduced, you got it, is also known as the oxidizing agent, which is very frustrating sometimes. So just realize that if you hear reducing agent or oxidizing agent, it means the opposite. So reducing agent means oxidized, oxidizing agent means reduced, etc., etc.
Nitrogen monoxide is a colorless gas, which we can observe when we bubble it through water. When it contacts air, and therefore oxygen, an oxidation-reduction reaction quickly converts it to nitrogen dioxide, a visible brown gas. When heated iron comes in contact with gaseous chlorine, a reaction immediately takes place, forming a dark brown solid, iron 3 chloride. This oxidation-reduction reaction involves a transfer of electrons from atoms of iron metal to atoms of chlorine, a halogen.
So again, here's how these different things can be used. Reducing agent means oxidized, oxidizing agent means reduced, and you can figure it out. Metals usually like to be oxidized around nonmetals. That's not all the time the case, but more often than not. So you can see, especially on the right side, that the iron is the reducing agent, i.e. it's being oxidized, it's losing its electrons, and vice versa, then chlorine likes to be reduced, which means it's the oxidizing agent. So it's kind of cool. Now notice here in these two examples, the left one is nonmetals plus nonmetals, and the right one is metals plus nonmetals. So redox reactions literally hit the gamut of possibilities when it comes to chemistry. They're in biochemistry, they're in inorganic chemistry, organic chemistry, all different types of bonding. They're a very, very important field, and you'll probably be hearing more about redox reactions in the future.